As the pin pitch of the components gets smaller, there is less room for the fanouts, so it becomes necessary to use a multiple row pattern. For this component, I want to create an even more complex fanout pattern with all of the signals fanning out to the inside of the component, but using multiple rows. I changed the settings to inside. All of the pins are fanned out in multiple rows on the inside of the component. For this component, I want to use a similar fan-out pattern, but with all of the signals fanning out to the outside of the component and using multiple rows. I changed the settings to multiple rows on the outside. All of the pins are fanned out in multiple rows on the outside of the component. This next component has an even finer pin pitch, so to make sure that there will be enough room for all of the signals, I am going to use an even more complex fan-out configuration that uses multiple alternating rows on both sides of the component. I changed the settings to alternating rows on both sides. All of the pins are fanned out in multiple rows on the inside and the outside of the component. For this very large quad component, I want to be sure that all of the signals will be accessible for post-assembly testing, so I choose to fan out all of the signals to both sides of the component. I changed the settings to both sides. All of the pins are fanned out in single rows on both sides of the component. In some instances, to conserve routing channels, it is preferable to only fan out the signals on the component that are actually being used in the design. I click the Undo button to remove the previous fan-out configuration. I select the same component again. Notice the markers that indicate that this component has already had fan-out settings assigned that differ from the design defaults. I change the settings to both sides and limit it to just the signals that are being used. Just pins with signals that are actually being used in the design are fanned out in single rows on both sides of the component. This BGA component is very dense, and I want to be sure that I provide adequate opportunities for routing out of all of the signals. To do this, I apply a fan out using a quadrant pattern. For this component, I select the BGA tab. In the alignment area, I select Quadrant from the drop-down list. I click OK to apply the settings. All of the pins are fanned out in a very neat pattern radiating towards the outside of the component and separated into a quadrant array. This BGA component has hundreds of pins, and I want to be sure that I provide a viable fan-out for each of the signals. To do this, I apply a fan-out using a diagonal pattern. On the BGA tab, in the alignment area, I select diagonal from the drop-down list. For the direction, I choose 45 degrees. Here, all of the pins are fanned out in a very consistent 45-degree diagonal pattern. There are many different ways to fan out a BGA. To try out a different option, I apply a fan-out using an X pattern. I click on the Undo button to remove the previously created fan-outs. On the BGA tab, in the alignment area, I select X pattern from the drop-down list. For the direction, I choose clockwise. Note that all the pins are fanned out in a very neat X pattern arranged in a clockwise direction. In this video, we have only explored a small sampling of the many possible configurations that can be used to create fanouts for components. Please continue experimenting to learn more.